They told me it was a waste of time, grinding out Redstone logic gates when I was 12. They told me that it would never translate into real-world skills, figuring out what the hell a comparator actually does. But they were all wrong. Because this, distinguished guests, was my final project for Computer Science 281 Assembly and Architecture at the University of Puget Sound, which means quite literally, Minecraft helped me get my degree. Cue the beauty shots. This CPU was, in fact, made in collaboration with Peer Carnes, a fellow student of mine, and you can check it out on the GitHub, because yes, this Minecraft world is on GitHub. It is not the fastest CPU, it's actually kind of a huge, slow mess, but it was both of our first Minecraft CPU, so I still think that's pretty cool. I also want to shout out Exabyte, who's this Redstone YouTuber who designed what we basically used for our RAM. This is slightly modified from what Exabyte made, but link in the description to Exabyte's video on making RAM compact, because believe it or not, this behemoth is quite compact for storing 16 bytes of data in Redstone. So we basically copied his RAM design. Shout out to Exabyte. So let's see this puppy in action. Here's the start-stop button. Let's flick it. The program currently loaded in, this is the program memory, which is again modified from Exabyte's design. It has a lot less stuff in it because it's read-only. There's no need to write to it. But this is how the program looks. The redstone blocks are ones and the empty black wool is zeros. And what it does is it clears the first two registers and then it does the Fibonacci sequence. And that's it. So it's Fibonacci, which is just adding the previous two numbers in a sequence to get the current number in the sequence. Y'all have probably seen this before. So right now we have a 1 here in this register, and that's going to get added with that register, and then the value of that will be put into this register. So this will get 1 in a few seconds. And then they'll be added together, and then this will get 2, and then they'll be added together, and this will get 3, and then this will get 5, 8, 13, 21, etc. And it'll go up to 200 and something, I'll put the number on screen, before it starts overflowing. So if you are not familiar with CPU architecture, a lot of this stuff won't make any sense, but the circuits are kind of color-coded. So we have gray, which is control, we have blue, which is clock. The white circuits are basically just buses. They're just connecting different components together. They kind of take up a lot of visual real estate, especially from a perspective like this. It's like my whole screen is just white wool blocks. But that's actually the simplest part by far in this whole thing because, I mean, just look. It's just a redstone line. That's it. Right, and it's just 8 of them next to each other to connect up different components, but they end up just going everywhere. This orange circuit here is the almighty ALU. So we've got AND, we've got XOR, I think that one's add, yup. We've got a NOT gate conditional on the end of that. The blue things are buffers that kind of either allow the signal to pass through 8 wide or not. As you may have seen, it is an 8-bit CPU, 8-bit registers, 8-bit slots in memory. However, since the program memory is only 16 bytes, the program counter is only 4 bits, because that's all you need. So here's the program counter over here. We've got another little adder here that just adds 1 permanently until it resets. It actually can reset, I suppose. Yeah, here's the clock. You've seen that before. That's the 0.1 hertz clock. Pretty cool, pretty cool. We're not using carpet mod here. This is all vanilla, so it probably could go a lot faster if we use the carpet mod, which is basically just a mod that speeds up Redstone in Minecraft. But it's easier to see what's going on this way. Where are we in Fibonacci? Oh, we're making it along. There's 8, so that this must be 13. Yep, that's 13 because that's 5 and then that's 8. Yep. So we're at 13, and next one will be 21 down here. Let's watch it change. Looks like the values are set up, and it just needs to do the right pulse, which will unlock these D latches. There it goes. Now we have 21 in there. So these are D latches. This is one way of making a D latch in Minecraft. There's many ways of making a D latch. And that brings me to the first interesting point, I think, which is that when building a Minecraft CPU, you never quite operate at the abstraction level of logic gates, but sometimes you work below the abstraction level of logic gates. Like these are D latches, which would involve like a ton of logic gates, but it's just a few blocks, right? So in this case, I'm definitely operating above logic gate level abstraction, because this is a whole D latch and it's just like a few blocks. But then in other cases, you have to build out multiple blocks to make a single logic gate, right? So, I mean, this from the beginning of the video, this is an OR gate, but even just an OR gate, which is arguably the simplest one to make, it requires several blocks at least, and that would be kind of an atomic unit if you were using something like Logisim to make a CPU. So it's kind of odd. Kind of on average, you're operating at logic gate level of abstraction, but you never actually work directly with logic gates because logic gates don't exist as fundamental elements in Minecraft Redstone. So that's kind of interesting. The other interesting point to make is basically clearing up a misconception that some people have that Redstone is a model of circuitry. It's not. Redstone really doesn't work like circuitry at all. It's analogous to circuitry, and I think that's why it gets confused sometimes. It serves a similar or analogous function to circuitry. And I mean, look, like we just made a computer. Like in real life, we make computers with circuitry. Here, I made a computer with Redstone, and there's a lot of very similar kind of design patterns and elements going on. However, Redstone doesn't work like circuitry at all. I mean, it doesn't even fit the name, circuit. You don't actually make circuits in Minecraft. You can just send a powered pulse in one direction. Like you just send it down the line and it ends at some point. You know, it doesn't go more than 15 blocks without a repeater, but you just send the power in one direction. You don't actually need to use a circuit. So it is not circuitry. It's easy to slip up and call it that. I call it that sometimes on accident, Redstone circuitry, but it's really not circuitry. There are no circuits. I mean, you can make circuits, but you don't need to make circuits to have electricity or the analog of electricity flowing, so to speak. So that's an interesting point as well. But that's about it. We made a custom assembly language as well, and there's a Python compiler for it, which basically just compiles MIPS style assembly that you write in a text file down to ones and zeros. Then I have to manually go in and actually like place the redstone blocks according to what the ones and zeros are. I have not gotten to the point of making an assembler that actually takes assembly code and translates it into like Minecraft block data so I can load it in directly. That would be pretty cool. I mean, feel free to make a fork of the project and do that if you want. But, you know, maybe I'll do that someday when I have way too much free time on my hands and no other projects, which is probably never going to happen. But that is just about it. So I wonder if we're overflowing yet. Ooh, actually, you know what? If we're not overflowing now, then we will be overflowing next. Yeah, next time. We might have already overflowed though. I'm not sure. Is that number? Is that? Can I get it all in shot? There we go. I wonder if that number is the max. I don't remember. I'll put on screen whether that was. Anyway, so that's it. Available for download on the GitHub. Just download it as a zip and then unzip it in your saves folder. Or clone it and do whatever you want. So there you go. That's it. Any questions, I'll answer in the comments, etc., etc. You know the drill. All right. Peace.